This is Unit 2, Lesson 6, Solving Systems of Inequalities. And our objective is students will be able to solve a system of inequalities. Now, solving systems of inequalities is very similar to just graphing an inequality. And it's also similar to solving a system of equations by graphing. So we're taking the concept of graphing and we're taking the concept of solving a system by graphing and we're just pushing them together. We have two vocabulary terms. The first one is system of inequalities. A system of inequalities is two or more inequalities of the same variables that work together. So for example, a system would be x plus y is greater than 10. That's one inequality. And then your second inequality might be 2x minus 4y is greater than 8. That's two inequalities. They have the same variables. They have x and they have y. And those two inequalities are going to work together in a system. Our second term is solution to a system of inequalities. This definition is a bit longer. It is the intersection of half planes. Remember we said in the last lesson that a system of inequalities shows the half planes. It shows only half of the quadrant plane where all of the solutions lie. So a system of inequalities is where those two half planes intersect. The solution is the set of all the points that make all the inequalities in a system true. So that's kind of a lot of words. Let's move on and look at an example so you can actually see what I'm talking about. The first step to solving a system of inequalities is to graph the first inequality. You'll notice over here I have two inequalities. They are x plus y is greater than 10 and 2x minus 4y is greater than 8. So I'm going to start out by graphing x plus y is greater than 10. And we're going to do all of that with this orange. So first I have to rearrange x plus y is greater than 10 and solve it for y. So I'm going to subtract x over, and I'm left with y is greater than negative x plus 10. So my y-intercept is 10, my slope is negative 1. Now let's count up to 10 on the x or on the y-axis. And we plot our first point there. And then the slope is down 1 over 1. Down 1 over 1. And if you remember, I like to do several dots when I'm doing inequalities because it makes the shading part a little bit easier. And all those dots will be connected with a dashed line since our inequality is greater than. It is a non-inclusive. Finally, I just need to shade, and it's greater than, so that means I'm going to go to my y-intercept and shade everything going up the y-axis, where all the values become greater. When you shade, shade very lightly. I'm going to use color, but you'll see I didn't try to shade this in thick. I just was very thin with my shading. So now that I've graphed my first inequality, we're going to move on to step 2, which is to graph the second inequality. And I need to rearrange this inequality because right now it is not in slope-intercept form. So first I subtract 2x. I'm left with negative 4y is greater than negative 2x plus 8. And divide by negative 4. Remember that when you divide everything by a negative, the sign flips to face the other direction. So that will become less than 1/2 x minus 2. I erased the work right there to give us a little more room. If you need that work, go ahead and go back and rewatch it. So my y-intercept is at -2, and my slope is 1/2. Up 1 over 2, up 1 over 2, up 1 over 2. And we're going to continue with that pattern. This is a greater than symbol, so once again, we're just going to do a dashed line. And then my inequality was less than, so I need to find my y-intercept, and I'm going to shade everything where the y values are less, which is down below. So I'll shade everything below that line. Once again, I tried to do my shading kind of light and thin. So the third and final step is to shade the area that overlaps. This is what I was talking about when I said the solutions is the set of all the points that make all this inequalities in the system true, or the intersection of the two planes. If you look over here, we've got the blue stuff all over here, the orange stuff all over here, and then there's this one section where the two of them overlapped. That's the part where we actually want to shade in. So I'm only going to shade the region that's between those two boundary lines. So it falls between the blue line and the orange line. It's where the blue line is less and the orange line is greater. All of the solutions to the system of equation fall in this region. I'm going to go ahead and do 2 more examples. And those examples will be good because they are a little bit different than this one, but they still follow the same process. All right, our 2 examples for this, or the 2.2 inequalities in the system are x plus y is greater than 2 and y is less than 2/3 x minus 1. Let's start out by rearranging x plus y is greater than 2. So I subtract x, and our inequality is y is greater than -x plus 2. The y-intercept is 2, slope is -1 over 1. And this is going to be a dashed line. My second inequality is already in slope-intercept form, so I can just go ahead and plot my y-intercept that's at -1, and then use my slope of up 2 over 3. Up 2 over 1, 2, 3. This one has a less than or equal to. The or equal to means that the boundary is inclusive. So we're going to do a solid line connecting those 3 dots. This time I'm graphing the lines first and then doing the shading after. It really doesn't matter which order you do it. All that matters is that you make sure the part that overlaps is clear that they are overlapping and you do it darker. So my less than or equal to means I shade everything below the y-intercept. So I'll shade all of this. And then my greater than symbol from the first inequality is telling me that I shade everything from here up above. When you look at the graph, you can see there is one part where it overlaps, and it is in this region where we have the pink and the green color. So sometimes people like to do this with the colored pencil, so they can use the colors to determine where they overlap. So I'm just like to shade very lightly. I don't really care which way you do it. I just want you to show the section that overlaps. Let's look at one more example that uses a special inequality. My first inequality in this last example is x is less than or equal to 5. Well, this is one of those special ones where there's only one variable. The only variable is x. So the only axis I'm going to be intersecting is the x-axis. I'm going to count over to 5 on the x-axis and plot my point there. My line is going to go straight up and down right through 5. It is not going to pass through any other x values. And I'm supposed to shade the region where x is less than 5. So if we look at the y-axis, the x values are greater when we go more positive and less when we go more negative. So I'm going to shade everything over here on the negative side. My second inequality is y is less than negative 3x plus 7. So we'll start at our y-intercept of 7 and then count down 3 over 1. There's the y-intercept, down 1, 2, 3, over 1. 1, 2, 3, over 1. And this one is going to be a dashed line. I need to shade everything that's less. So we find our intercept and we're going to shade everything down below it, which is this region. The part that overlaps is along this line, and then it kind of bends when we get here. So we're going to shade in that region. Be careful not to cross the blue line up here or the pink line down below. So that's how we solve a system of inequalities. It's really not much different than just solving a plain old inequality with a graph. The only difference is that we overlap the two graphs rather than just doing one at a time.